Ladies and gentlemen, welcome to this episode of my tutorial video channel. This episode is on economic order quantity or optimum order size. Economic order quantity is a very important concept in inventory control and management. Every business must have some inventory to carry on the business process. In case of manufacturing industries, it can be raw material. In case of engineering firms, it can be spare parts or components. And in case of retail businesses, these are all finished goods where the retailer purchases the finished goods and sells in the market with the profit margin. Anyway, there must be some inventory involved in every kind of business. Now, economic order quantity or optimum order size is that size of the order which makes the total inventory cost minimum. Right? Now, in this episode, I will discuss economic order quantity. Basically, it is a model of inventory control. So, what is economic order quantity? What is carrying cost? What is ordering cost? How the minimum cost is arrived at, and how the economic order quantity formula is derived by using simple arithmetic as well as by using calculus. And after that, I will solve one numerical problem on economic order quantity. So first of all, let us discuss what is economic order quantity. EOQ, also known as optimum order size. As I said right now, economic order quantity is that quantity of the order which makes the total inventory cost minimum. Now, inventory cost consists of two elements. One is carrying cost and the other is ordering cost. Carrying cost means the cost of holding the inventory, and ordering cost means the cost of placing the order. Let us take an example. Suppose a farm needs 365 units of a particular inventory, of an inventory annually. So annual requirement of the farm is 365 units to carry on the production process throughout the year. Now the farm can procure these 365 units in different order sizes. Say, here we make two columns. One is order size and the other is number of orders. Right? Suppose the farm is procuring the full shipment of the annual requirement in one go, that is by placing one order. So number of order is, in that case, is 1 and the order size is 365. Right? Or the farm can place two orders to procure the 365 units. So order size will be 365 by 2. If the farm places 3 orders, then the order size will be 365 by 3, so on. So at the other extreme, there can be a scenario where the farm is placing 365 orders and the order size is 1. Right? Now, in this case, order size is 365 and number of orders is 1. This means the farm is holding this inventory for the whole year, or the farm is carrying the inventory. The farm is storing the inventory in its storage space. All costs involved in carrying or holding the inventory are known as carrying costs or holding costs. And look at this other extreme. When the order size is 1, that means the firm is placing order for 1 unit at a time, and throughout the year, every day the firm is placing an order. Number of orders is 365. This means here the firm is not carrying the inventory, but the firm is placing 365 orders. Here the firm is placing only 1 order. So these are the two extremes. Carrying cost is related to this, that is carrying the whole inventory, and in this case the firm has to incur more ordering cost as number of orders 365. In this case there is only 1 order, so ordering cost is minimum, right? Now we shall discuss what are the costs under carrying cost and ordering cost. I am addressing this part, okay? Yeah. So inventory cost has 2 categories. One is carrying or holding, and the other is ordering or not holding, right? Now if the firm carries the inventories, then these costs are involved. Number 1, pilferage. Number 2, spoilage. Number 3, breakage. Number 4, insurance. More stock is stored in the stores, more is the insurance premium. Number 5, obsolescence. There is a risk that the inventory can become obsolete in the middle of the year. So these are the carrying costs. And of course there is the opportunity cost. Why that is opportunity cost? Because if the firm procures the full shipment of the whole year in one go, this means much capital is blocked in the inventory. So there is certainly opportunity cost. And what are the elements of ordering costs? Number 1, communication. More is the number of orders you place with the suppliers, more is the communication. That means more is the communication cost. Number 2, transportation. Shipment, shipment. More the number of orders, more is the shipment cost, more is the transportation cost, because every time you have to take the shipment. Unloading cost. When the whole consignment for the full year is taken in one go, the firm is once unloading the inventory. On the other hand, if number of orders is much more, 10, 20, 30, 40, 50, 60, etc., in that case, every time the firm has to unload the materials, and that involves a cost. And number 4, very important, stock out cost. If the order size is very low, that means number of orders is very high, then there is the risk of the firm running out of stock, and this stock out will ultimately hamper the production, which will in turn result in loss of sales. So these are the 2 types of costs involved in inventory cost. That is ordering cost and carrying cost. Now I will derive the formula of economic order quantity arithmetically and with the help of calculus. I am erasing this part, okay? Yeah. EOQ, that is economic order quantity, is equal to root over 2 into annual demand or requirement or consumption by the production department. You can use any term. 2 into annual demand into ordering cost or order placing cost per order divided by carrying cost per unit. This is the formula of EOQ. We can write in abbreviation like this: 2 into A into C sub O divided by C sub C. This is ordering cost per order, and C sub C is carrying cost per unit. Now this formula can be derived in 2 ways, and I shall show the 2 ways of deriving the formula of EOQ. Suppose let the annual demand be annual demand, that is requirement by the firm of that particular inventory. The annual demand or requirement of the inventory is equal to, say, A. The ordering cost per order is equal to C sub O, and carrying cost per unit is equal to C sub C. C sub O is the ordering cost per order, and C sub C is the carrying cost per unit. Right? Since annual requirement is A and ordering cost is C0 and carrying cost is CC, we have to assume one order size. Let the order size be Q. The order size be Q. Now look at this graph carefully. If we measure time on x-axis and quantity of order on y-axis, say this is Q, this is T1, time 1, time 2, time 3, time 4, time 5, time 6. Now with passage of time, the total quantity order will be exhausted, then it will be replenished, then it will again be exhausted, then it will again be replenished, then it will again be exhausted, and this will go on. So, how much quantity the firm is actually carrying throughout the year? To say that answer, we take average quantity. Say this is Q, so this is Q by 2. So Q by 2 is the quantity of that inventory which the firm is carrying throughout the year. Put it in other way, at any point of time during the year, there must be Q by 2 units of the inventory with the firm. Right? Now, since the order size is Q and the annual requirement is A, certainly number of orders will be A by Q. A by Q will be the number of orders. Therefore, ordering cost will be ordering cost annually. This is annual ordering cost. This is ordering cost per order. C sub O is the ordering cost per order, and A by Q is the number of orders. Therefore, annual ordering cost is equal to A divided by Q multiplied by C sub O. Right? A by Q is the number of orders into C sub O is the ordering cost per order. Right? The annual ordering cost is A by Q multiplied by C sub O, and the annual carrying cost is equal to Q by 2 multiplied by C sub C. C sub C is the carrying cost per unit, and the number of units throughout the year with the firm is Q by 2. You have taken average of the ordered quantity, so Q by 2 into C sub C is the annual carrying cost. Right? Now, look carefully. In ordering cost, Q is in the denominator, and in carrying cost, Q is in numerator. Therefore, ordering cost varies inversely with quantity, because Q is in the denominator, and in case of carrying cost, Q is in the numerator. Therefore, the annual carrying cost varies directly with quantity. Correct? So, and what is Q? Q is the order size. So, the annual ordering cost will come down as the order size increases, and the annual carrying cost will go up as the order size increases. Right? So, if we draw a diagram, this is order size. This is ordering cost, and this is carrying cost. Right? As the order size is more, less number of orders will be placed, so ordering cost will be downward sloping curve. And since carrying cost is directly related with the order size, so as order size increases, the carrying cost will go up. And the two curves intersect at this point. Say this is point M. Now look at the total cost curve. This is the total inventory cost curve. That is ordering cost plus carrying cost. Inventory carrying cost is the sum of ordering cost plus carrying cost. Now look carefully. The total cost is minimum when the ordering cost curve intersects the carrying cost curve at point M. This means total cost is minimum when the ordering cost is exactly equal to the carrying cost. That is, the annual ordering cost is exactly equal to the annual carrying cost. Say this is Q. So OQ is the economic order quantity. For OQ order size, the total cost of inventory of the firm is minimum. Now, therefore, to minimize cost, to minimize inventory cost, ordering cost must be equal to carrying cost. This means A by Q into C sub O will be equal to Q by 2 into C sub C. This means 2 into A into C sub O is equal to Q square C sub C. This means Q square equals to 2 into A into C sub O divided by C sub C. Therefore, Q equals to root over 2 into A into C sub O divided by C sub C. So, we have derived the formula of economic order quantity by using simple arithmetic. It is very simple. The total inventory cost is minimum where the ordering cost is exactly equal to carrying cost, and we have simply equated the annual ordering cost and annual carrying cost to find out the value of Q, which is root over 2 into annual requirement of the inventory into order placing cost or ordering cost per order divided by carrying cost per unit. Correct? Now I shall derive the same formula by using calculus, and for that I have to erase this diagram. I am erasing this diagram, okay? Because I am facing a lack of space. Until I erase this part, I cannot proceed further. So I take liberty to erase this part. Here I will show how you can derive the formula of EOQ by using calculus. Now, total inventory cost. Total inventory cost, let it be I, is equal to ordering cost plus carrying cost Therefore, I equals to A by Q into C sub O plus Q by 2 into C sub C. equals to a into q to the power minus 1 into c sub o plus q by 2 into c sub c. Right? Now we shall differentiate I with respect to q. Differentiating I with respect to q, we get del I del q equals to ddq of aq to the power minus 1 into c sub o plus q by 2 into c sub c. Now we know in differential calculus, if we differentiate this function, then it may be cost or it may be anything. That is minimized when the first order derivative is 0. That means the total cost, total inventory cost will be minimum when del I del q will be equal to 0. That is ddq of aq to the power minus 1 into c sub o, that is the ordering cost, plus q by 2 into c sub c, that is the carrying cost, will be 0. So we have to set it 0. At minimum cost, del I del q equals to 0. So we differentiate this, what we get? Minus 1 a into q to the power minus 1 into c sub o plus half into c sub c. Right? Now this will be equal to 0. This means a q to the power minus 2 into c sub o is equal to half c sub c. Right? This means a into 1 by q square into c sub o equals to half into c sub c. Right? This means we just cross multiply 2 into a into c sub o equals to q square into c sub c. So this means q equals to root over 2 into a into c sub o divided by c sub c. The same thing, the same formula. So in this section, I have derived the formula of economic order quantity by using simple arithmetic, and in this part, I have derived the formula by using calculus, and both lead to the same result, same answer. So this is all about derivation of economic order quantity. Now economic order quantity is basically inventory control model, and this model is based on certain assumptions. Right? Now what are the assumptions? So I have to erase this part, that is the derivation part, so that I can proceed to assumptions, and after that I shall solve one numerical problem. So let me erase this part, this derivation part. Okay? Yeah, I am compelled to erase it because I have to proceed to assumptions, and after that solution of one numerical problem. So EOQ model is based on certain assumptions, and what are the assumptions? Assumptions EOQ model. Number 1, the annual demand is fixed. Annual demand is constant. Number 2, the lead time is known and constant. What is lead time? Lead time is the time lag between placing the order and receiving the shipment. This is lead time. There is maximum lead time, minimum lead time, average lead time, and there are other formulae of economic order quantity model like maximum level, minimum level, reordering level, etc. Those I will discuss in some other video. In this video, I shall focus on derivation of economic order quantity, carrying cost, ordering cost, the assumptions, and solution of a numerical problem. So the assumption number 1, annual demand is constant. Number 2, the lead time is known and constant. Number 3, ordering cost per order. Ordering cost per order is constant. The ordering cost or order placing cost per order, that is the cost of communication, cost of transportation, cost of unloading, etc. This cost is fixed per order. Number 4, carrying cost per unit is constant. In most of the sums, the carrying cost is given as percentage of material price, that is inventory price, purchase price, right? And in many sums, the carrying cost is given as return on investment, that is the 10% is the return on investment. Then consider 10% as the carrying cost per unit, 10% of the material price, inventory price. Number 4, there is no quantity discount. The firm is not getting any quantity discount. So these are the assumptions on which the economic order quantity model is based, right? Now I shall solve one numerical problem, discussion about economic order quantity, carrying cost, ordering cost, and drawing the carrying cost, ordering cost curve and total cost curve, and showing the minimum point. All these things are over. So now I shall solve one numerical problem. The annual demand or requirement or consumption, same thing, demand or consumption or requirement, 15,000 units. So annual requirement by the firm of a particular inventory is 15,000 units to carry out the production throughout the year. Ordering cost per order 10. Material price or inventory price 5 per unit, and carrying cost is 20% of material cost, that is material purchase price or inventory purchase price. So annual requirement is given 15,000 units, ordering cost per order is 10, material price is 5 per unit, and carrying cost is 20% of material cost, that is 20% of 5. So EOQ is equal to 2 into annual demand into ordering cost per order divided by annual carrying cost per unit. This is the annual carrying cost per unit, right? So we simply put the values as given in the question. So this is equal to 2 into, what is the annual requirement? 15,000. 2 into 15,000 into ordering cost per order is 10. So we put 10 divided by annual carrying cost per unit, that is 20% of 5. So this becomes, let me use calculator. Okay, 3 lakh, that is 300,000. Into 15,000 into 2 is 30,000 into 10, 300,000 divided by 20% of 5. This is 1 root over this. So the order size is 547.72. $547.72 is the order size. That is, this is the economic order quantity or the optimum order size. By ordering this much in one order, the firm will be minimizing the inventory cost. That is, for this order size, the ordering cost will be exactly equal to the carrying cost, right? So this is enough for economy order quantity. I hope this is well understood by you. Still, should you have any doubt in your mind, should you have any query, if you think any particular point needs further clarification or explanation, please let me know through the comment box. I shall be more than glad to answer to all the relevant queries and doubts. And if you think this video has benefited you or is going to benefit you, then please do share the video with your friends, brothers and sisters, so that they can also obtain benefit by watching this video. And I also would request you to like and subscribe my channel. And finally, thank you very much for watching this video. Stay well and goodbye.